Hey, Palmerettis, I hope you had a good Easter. Hopefully you're doing well. It is Monday, April 13th. Got my great graphics going on right here. My graphics department is awesome. We are dealing with math pages. Natalie, this is for you, colored pages, 505 and 507, so get those out. Homework page, 175, and then the front and back. Remember, when you send pictures to me, I just need the homework page, okay? This is lesson 13.7, by the way. So we just tackled area and perimeter last week, and this is going to kind of tie up a little bit of everything that we've seen. So dig in with me, looking at this page right here, and let's walk through it, read through it, make sure we're ready to rock and roll, okay? So Mr. Beasley's science class wants to decorate one wall in the classroom like an underwater scene. They use sheets of blue poster board that are 2 feet long and 2 feet wide. So right away, we know that we've got some poster board to cover up the wall. So imagine I give each of you a sheet of blue paper that is 2 feet long and 2 feet wide. Okay? 2 feet long, 2 feet wide. Okay? There's your length, there's your width. How many of those sheets is it going to take to cover this entire wall? So this right here is the wall. Okay? That's what they don't tell us. Here's the wall. The wall is 14 feet by 8 feet. Length, width, base height, don't care which way we go. So as we look at this, we've got to figure out this right here first, okay? Now, are they asking us for perimeter or area? Well, to cover this entire wall would be area. So if I gave you each a blue piece of construction paper that was 2 feet by 2 feet, what's your area? Exactly. Area is 2 times 2, so it's going to be 4 square feet. So each blue piece of paper that you give me can cover up 4 square feet. The question is now, how many of those are we going to need to cover up this wall? Well, 14 and 8, okay? So come down here. Let's do it down here. We're going to calculate the whole area of the wall. So 14 times 8. Work on that one for me. As I'm reading this, how can you calculating the area of the whole wall and the area of one sheet of poster board help you determine the total number of sheets of poster board needed to cover the entire area of the wall? Area, covering the wall, painting the wall, right? What'd you get? 8 times 4 is basic math fact, 32. Study those basic math facts, memorize. 8 times 1 is, plus 3 is 11. So it's the whole wall is 112 square feet. Each square that you give me covers 4 square feet. So to figure out how many of those we need, if each of you walks up to me with a piece of paper that is 4 square feet and we start putting it out on our wall where we need 112, what do we do with these numbers? Do we add them? No. Do we subtract them? No. Do we multiply them? Think about that. That would be 4 times 100, be over 400 square feet. Wouldn't make any sense. We're going to take 112, divide that by 4. So here's your long division, right? Notice how that doesn't leave us. 1 divided by 4, can't do. 11 divided by 4, 4 times 2 would be best. You get your 8. We divide it, we multiply, we subtract. Now we bring down. 32 divided by 4. If 4 times 8 was 32, 32 divided by 4 is 8. We get 32. And our final answer is we're going to need 28 pieces of those board. So if we're sitting in art class, if we're sitting in this classroom, we're going to have 28 of those blue poster boards to cover this entire wall, okay? All right, so we saw area there. We tackled area. Review that real quick. Flip it over. Now we get into some fractions, and it goes back to work that we saw in topic 12, and it's building on our lessons that we already know. So Piper has a fish tank and wants to cover all 4 sides 6/10 of the way to the top with clear plastic for insulation. She measures and finds the dimensions shown. How much plastic does Piper need? Use your math words and symbols to explain. So let's see how she does this work here. So the length is 12 inches, the height is 15 inches, and the width is 24 inches. So she has length times width times height. That is 3 dimensions, guys. That is your 3 dimensions. You had a science page talking about if we had how does 3-dimensional maps help us? Because we can see the length, we can see the width, and now we can throw in the height, how tall it is, be it a mountain, be it a building, be it a cell tower. Those things that are taller, and that's where those 3 dimensions come in. So what do we need to know so we can solve this problem? Well, she needs to find how much plastic is needed for the fish tank. She needs to be precise in her calculations. So again, this last lesson, every last lesson tells us things we need to do. correctly use the information given, calculate it accurately, decide if my answer is clear and appropriate, does it make sense, use the correct units. So she takes the height, and she wants to go, the height of the plastic is 6/10 times 15. We've seen this before, guys. The 10 stays the same. 6 times 15 is 90. Divide that, and she gets 9. So she's going to take the front and the back. 9 times 24, she got 216. Each side, 9 times 12, she got 108. So she has the front and the back and each side. So she does the front and the back and each side. And that's where she gets 648 square inches. Now, was she going to need the clear plastic on the top? No, because that's the lid. Is she going to need it on the base, the bottom of the tank? No, because we're not going to see that. So she only did the 4 sides. Review it, all right? You used your math words there to multiply, you divided, you got area, those kind of things. So just walk through that one. Okay. Now, when you are precise, you calculate accurately. This one's a little bit challenging, but it's going to kind of tie into some things that we've already seen. So a few notes. You're going to look back at page 482. Okay, page 482 that you already have at home, and you're saving all your math pages. Jeremy uses 2/3 yards of tape for each box he packs for shipping. How many inches of tape does Jeremy need to pack 3 boxes? So if you go back to page 482, you see that 1 yard equals 3 feet. What does 3 feet equal? 36 inches. So 1 yard, right, equals 36 inches. We're using 2/3 of a yard for 1 box. So how many would we need for 3 boxes? So find how many inches we need to do. So we're going to do our math. Now, there's all kinds of wording here. And again, you would hopefully explain it to your parents, your step-parents, your grandparents. This is just so it explains your thinking. I want you to show the math, okay? So if we have 2/3 yards, right, okay, and we want to do that for 3 boxes, right, 2/3 times 3 is 6/3. What do we do with that? Yeah, we divide that. We get 2. So we're going to need 2 feet for each box. Now, take that 2 feet, and we want to convert that into our inches. So 2 feet equals how many inches? Well, 1 foot is 12 inches. So 2 times 12 means we've got 24. All right? So we got 24 inches. So there's 24 inches and 2/3 feet. Oh, wait, no, 2/3 yards. Oops, see how I caught my mistake. Okay, so there's 24 inches and 2/3 of a yard. Now, how many boxes were there? 3 boxes, right? So 3 boxes. Each box is 24. So, right? Each box is 24. So 3 times 24. You're going to get 72 inches. Okay? So let's walk through this one again. You had 2/3 yards times 3 boxes, right? Did I say 2 feet? Uh-oh, that should be 2. Yeah. Okay, 2/3 yards. All right, you got 6/3. So that's going to be 2 feet. Convert that 2 feet into the inches. Turn that inches to 24 inches as in 2/3 of a yard. Okay? Tricky problem. Walk through it. Pause it. If you catch anything, I'm thinking through some things right now as I'm reviewing it right now. Something's bothering me. I can't figure out what it is. But conversion. So 3 boxes. So if 2/3 yards is 24 inches, 3 boxes would be 72 inches. Now, Mrs. Reed, she's going to get into using page 490 because Mrs. Reed, let me make sure we can see it. Okay? She's going to collect shells. Each shell in her collection weighs about 4 ounces. Her collection weighs about 12 pounds. Do you already notice it? Yeah, ounces and pounds. So back on page 490, 1 pound equals 16 ounces. See how they're taking us back? Okay. So how can you use information given to find out how many shells she has in her collection? So if she has 12 pounds, and she wants to know how many shells she's going to have, we've got to turn pounds into ounces. So we've got to turn pounds into ounces. How do you do that? Well, 1 pound is 12 ounces. You're going to do 12 times 16. So haven't taught you the 2-digit by 2-digit yet, so we're going to go to our old trusty box method. Okay? 16 times 12. 16 times 12. Up here, 10 times 10, 100. 10 times 6, 60. Are you with me? 2 times 10 here, 20. 2 times 6, 12. 2 times 6, 12. Now, what do we do with all those numbers? We add them. 100, 60, 20, 12. 2, 6, 7, 8, 9, 192. Okay? Walk through it. Pause it if you have to, guys. Pause it. Replay it. So we've got 192 ounces, OZ for ounces. But how many shells? Okay, if each shell weighs 4 ounces, we're going to do 192 divided by 4. So now we come back to our long division. Okay? You with me? Pause it again. Can we do 1 divided by 4? 19 divided by 4 goes into it 4 times because 4 times 4 is 16. Subtract that, we get a 3. There's that 2 again we saw earlier. Terrible 2. 32. Oh, that is terrible. 32 divided by 4. We're going to put an 8 up there. We get 32. And our final answer is that each shell is she's going to have about 48 shells. Okay? So what did we do again? We knew that pounds equals ounces. So 12 pounds to ounces is 12 times 16. So we did this work right here. 12 times 16 and got 192. So the shells weigh 192 pounds, 192 ounces. We divide that by the 4 ounces, and we know that she has 48 shells. See all the steps that are involved there? Yeah. Let's flip that over. All right. Okay. Tanisha is making cards by gluing 1 ounce of glitter on the front of the card and then making a border out of ribbon. As soon as I see that word border, I'm thinking perimeter. And I'm going to write my little note up here. 2 times width, 2 times length plus 2 times width. As soon as I see that word border, border is going to go around it. She makes each card dimensions shown. How much ribbon does she need? So let's look at it. 85 millimeters, 9 centimeters. Bingo! Go back to page 494, and you'll see that 1 centimeter equals 10 millimeters. So who's going to change? That's right, this guy. 9 times 10, we're going to get 90 centimeters. Okay, again, all of this is just what your thinking is. What quantities do we use? What's given to us? What do we need to find? What are the hidden questions that must be answered to solve the problems? Well, our hidden question was 9 times 10 equals 90 centimeters. We already did that. That's that hidden question right there. Okay? Now, they want to know how much ribbon does Tanisha need. So we're doing border, so we're going around it. Okay? All right, you with me on that one? So she's got 90. So if we look at this, this is 90. That's a 90. That's an 85. That's an 85. So you do 90 times 2, 85 times 2. Double those. If you have to do it over onto the side, do it right here. 90 times 2, 9 times 2, 18. We've got 180. 85 times 2, get 170. Add those up. So perimeter equals 2 times the length, 2 times the width, and then you add them together, and what do you get? 350. 350, put an mm for millimeters. Okay? See that steps right there? What information was not needed in this problem? The glitter. The 1 ounce of glitter. The 1 ounce of glitter was what we call the what? That's your distractor. Okay? So as you reread that problem again, the tricky part was seeing that you had a centimeters and a millimeters. Guys, that comes with carefully reading. If you do not carefully read your instructions in your problems, that's when you're going to have those hiccups and those mistakes. So millimeters, centimeters, eyeball it, find it, and then make those corrections. Go back. Notice how we've gone back in all these color pages. We went back to previous lessons. Review, review, review. We are finishing topic 13 today. Once you get this homework done in there, we have 3 topics left to do. So my suggestion is to review those 13 topics. Get on your eye ready to at least 10 to 15 minutes a day, okay? All right, so let's look at the homework page. All right, the homework page, we're going to talk about it. I'm going to release you on your own to do this one, and this one's going to be due Tuesday or just get it in by Wednesday, okay? But Tuesday would be great since it's Monday. Mio, here you go, Mia. You have a length of string that is 2 meters long. You cut it into 4 equal parts. Is one of the pieces of string long enough to tie around the perimeter of a square box with a side length of 16 centimeters? Explain. So they're asking you, is it long enough? So it's a yes or a no, and then explain it. Tell how you can solve the problem. Again, these are the steps that we can do. Common sense, doing it accurately, using information. Well, first she had to convert meters to centimeters. Okay, so she had to use our cheat sheet, our reference sheet, that 2 times 100 equals 200 centimeters. There we go. Next, find the length. So 200 divided by 4, that's 50. They didn't show their long division work. Very upset with them here. And then they did 4 times 16. They didn't show their work, but you can just review it. Here's your first homework assignment. Okay, again, all these answers here, just show me the math and get me your answer. Susan bought 1 kilogram bag of grapes. On the way home, she ate 125 grams. Couple things here. Kilograms, grams. Okay, you noticed something already? Okay, so you need to know that 1 kilogram equals 1,000 grams. Where is that? Go back in your colored pages and find it. So turn this kilogram into grams. Then you ate, out of that 1,000 grams that you had bought of grapes, you ate 125 of them. How many grams do you have left? How many grams do you have left? I want to see your answer there. All right? Second problem. Check this one out. Cell phone pouches. Check this out. You're at home. You're like, you know what? I want to make some money. Other than making masks, you're going to make some pouches for people's cell phones. You want to make phone bags like the one shown. The pattern shows the material he needs for each side. Each side. How many sides are there? A front and a back. 2 sides. There is something you've got to be careful with. You're doing 2 sides. Write that note down. Okay? He needs to know how much material he'll need to make each bag. He knows this side is 3 inches. This side is a half of a foot. So what do I need to know? Well, I need to know that 1 foot equals 12 inches. Okay? So what would a half of a foot equal? So you're going to change that guy and convert. Show your work, guys. Convert him. Now, once you have this guy in inches and you have this guy in inches, you want to do this whole side. So what are you dealing with here? Are you dealing with the perimeter or the area? You're dealing with area equals length times width. Once you change this half foot to inches, you're going to have this side and that side. Plug it in and get your area. But remember, it's 2 sides. So how much are you going to need? Find out this side. It's the same amount on the other side and get me your answer. Okay? All right. There's also down here it says what information was not needed. What was the distractor in this problem? What's the distractor? Tell me what the distractor is. So again, don't panic about all this reading. Show me the math. Convert, get the area, do it for the front and the back. Tell me what the distractor is. Cool beans? All right, guys. Have a good one. I'm here to help you. Miss yous.